today. So a couple things that I wanted to let you know is includes, first of all, there will be a prize. So sometime during today's session, this afternoon's session, you might receive a private message from an account called First2 Network on this here chat platform that will possibly let you know that you have won a $25 Visa gift card. So stay tuned because there is a prize. We also want to let you know that at the very end, we will give you a link to a very brief evaluation survey because one, we are all researchers and evaluators and we want to know what you think. And number two, we also understand that you're very busy, so it is short. Welcome everybody. If you have burning questions as we go through today, please write them in the chat and we'll do our best to answer them after each presentation. And if we can't get to them, we'll write them down and get back to you later. So first of all, it is my very great pleasure to introduce to you members of the First2 Network's evaluation team. That includes Marjorie Dara, can you wave? Say hi. Roxanne Humbert, John Stewart, and Gay Stewart. Also with me today is Jonave Campbell, who is a member with me of the evaluation team. So first we're going to hear from members of the evaluation team divided into two sections. One group of folks will tell you about some quantitative data. Another group will tell you about some qualitative data. If I remember correctly, I think, John, you're up first. Is that right?
I think that's right.
Okay. I'm going to hand things over now to John Stewart, who heads up the quantitative research team.
I'm not sure I see any of my students. I actually have no students now. I put in grades last night. I don't see any former students here, but there are a number of people in the talk. So first, I'm going to talk about the retention of rural and first generation engineering students at West Virginia University. This is work I'm doing with Elaine Chrisman, which I did see here. And I have to say, as I give these talks at the at a First2 meeting, I know that there are a number of first generation rural students in the audience, including my wife, who is Gay Stewart, who's part of the grant. And we do talk about there being a somewhat higher risk of not making it through college. But I have to put that in context. Those additional risks are not that big. So everybody here can successfully earn a college degree and go on to be a successful STEM person. All right, so first, preliminaries. So what are we going to talk about? So this is going to be data we took from West Virginia University over a long time, from 2005 to 2014. So we're giving everybody 6 years to graduate. And this is going to be people who, at some point in their undergraduate career, elected an engineering major for 6,500 students. And we're going to look in on that, because the folks who have attended many of these, we reported last time that it looks like, for rural students at least, the additional risk seems to be localized in kind of the more hardcore mathematical physical science majors. So we're going to look at engineers who have a very well-defined, if you are an engineer, very well-defined career path, including a bunch of mathematics classes. We restricted these students to being students who enrolled as a freshman, so not transfer students. And we required they have a high school GPA and ACT or SAT score included. And then we restricted it to only students who attended high school in West Virginia. So everybody in this data set are West Virginia high school students at least. We use the definition of first generation that WV uses, which first generation students are students who neither parent completed a four-year college degree. And I think Margie is going to drill down on this definition a little more, because this is really pretty restrictive. Oh, we've talked about rural before. There's many, many ways the US government defines what a rural and what an urban student is. And we've presented a number of them. We're going to use the National Center of Education Statistics classification. And they classify high schools, or the cities in which high schools reside, on a 12-point scale. And we're going to take the last two green ones down here, which probably aren't readable, but they weren't readable last time, so at least I'm being consistent, as the our rural students. They're very, if you look at the kind of cities that have high schools with these classification, I think they fit pretty well with what a West Virginian would say is a rural location. Okay, so they're called locale codes, and and they're locale codes 42 and 43, but we can ignore that. We'll call them rural. So let's look at engineering students. So in this talk, I'm going to show you a number of ways to visualize retention. And this is where I've been doing this for years. So what I'm doing is moving around Zoom windows. So Caitlin has a comment. Yeah, so I've been here 6 years. I'm still a newcomer. But I'm not rural at all or first generation. So first visualization, and note the colorblind palette. This is called the Sankey plot. I love these. And it's going to take a while to unpack what's sitting here. So this is engineering majors. And these are semesters along the bottom axis. So this semester here, and I hope you can see the cursor here. This first semester is your fall freshman semester. You can see they come in 2 semester groups. That's because I wiped out the summer semester. And so anything bad that happens in the summer semester get dumped back in the spring. So see 2 years fall, spring, and then here's sophomore year, here's junior year, here's senior year. People start graduating, and so this is 6 years worth of data. And this shows you how people flow between the long green bar is engineering students enrolled in an engineering major. And the short yellow bar is other STEM majors like physics, which is where I live. And then, so the brown bar is non-STEM majors like psychology. And I know psychologists think they're STEM majors, but the National Science Foundation disagrees. So we'll go with them. And this shows you the flow. So, and what we're worried about is this green bar here at the top. That's people who leave college. We're also worried about people who leave STEM going into the brown bar. And those are people who at some point were engineers but will not graduate with an engineering degree. And see, it sort of works like you think it would work. So we go for about 4 years and people start graduating. So they start being good stuff, this orange stuff, graduates engineering. But they also, there's people don't graduate, the green bars gets bigger. And then people go from engineers into non-STEM majors. You can see a lot of that happening after the first semester and then after the 4th semester. And so this kind of gives you a picture. So this is kind of a slideshow, and I hope this is visible because I wasn't sure it's going to be. So this is everybody. So now I'm going to switch to just rural students, and we're going to watch that green bar at the upper right. And you see the green bar at the upper right got a little bigger. And that's because more rural students do leave college without a degree. But it was pretty, that's not a big change, right? So I'm going to go to first generation students. And slightly worse again. So more first generation students than rural students leave WVU without getting a college degree. Yeah, but kind of qualitatively, those were not big changes. So we're talking about about differences that are not huge. So if you're a first generation student, you have every right to believe that if you put in the work, you'll get through college successfully, including being a rural student as well. Oh, and this is the combination. It kind of averages. All right, so a lot of this stuff is most natural if you're going to talk about it in terms of something called survival analysis. This is kind of a branch of mathematics was invented to talk about medical diseases, right? So if you begin to learn about survival analysis, the examples are all great stuff like colon cancer. But basically going through college is kind of like that, where you want to survive, you want to stay a college student until you graduate. And so we'd like you to survive to graduation. And so for now, we're just going to start with students who started with engineering major. They elected an engineering major their first semester in college. And people leave engineering majors through 3 pathways. They graduate, good stuff. They change majors, and you saw from the Sankey plots, mostly they don't change majors to other STEM majors. Mostly they change, let me go back here. Mostly this brown bar at the bottom is getting bigger. Those are non-STEM majors. This little yellow bar is tiny. So people who leave engineering generally leave for non-STEM majors. Or they leave college. So the question is, the far bar at the right is 6 years, yeah. Yeah, and the question is I guess I should have, this is where, this made my lectures really interesting, of course, semester. Yeah, there's still people down here. This brown stuff here, these folks are still in college. And and that is, lots of people we'll see graduate successfully in 4 years, some people in 5 years. But people are still, there are some people still remaining by the time they get college. Okay. All right. Now I'm lost. This is what happened in my lecture too. Okay. So we can look at the fraction of people who have left through different paths, either leaving college, graduating, or changing major. We can plot that up. And so here, green is non-rural first-gen students, red is first-generation students, and blue is rural students. Those locales 42 and 43. And you can see that there are a higher fraction of folks leaving college, both for rural students and for first-generation students. We do have some work to do there. But if you'll notice also, these numbers aren't particularly high. This is the highest is for first-generation students at 6 years, and that's still 25%. Okay, and these, once again, these are all engineering majors who elected engineering the first semester in college. Now we can get the part that I like. So this is, so survival analysis, they talk about hazard. And hazard's what we really care about. It's the odds the bad thing's going to happen right now. So the hazard or the risk is the fraction of students who are, say, currently enrolled in a semester who leave before next semester. So it's basically the rate people leave college. And this will show you why the first 2 name came from, and maybe we should worry about first one first. So this is the leaving college risk. And you'll notice it's jagged. And the jagged actually makes total sense. Here, this is the freshman semester, freshman fall, freshman spring. So students enrolled, they're not doing so okay, but they hang out because they paid the rent for their apartment. And they go home after their freshman year, and then they don't come back. This risk is not coming back after the freshman year, and you can see there's an equal, it's not as big, but there's also a risk after not coming back after the sophomore year, hence first 2. What was surprising, and I didn't know this until a week ago, is that the risk pretty much flattens out for the rural and the just students who aren't rural and first gen. It doesn't flatten out for the first generation students. You can see they're still very up and down. So we have a decent amount of risk for first generation students not returning after their junior and their senior years. This would be, and so this is something maybe we need to look at support for those students later in college than we've been thinking. If we look at just leaving the major, leaving engineering, it's very similar between the 3 groups of students. So the additional risk for rural and first generation students really does seem to be within the leaving college rather than leaving STEM. And I can look at the hazard there too. And this all totally makes sense too. The bumps here at the fall sophomore semester. And that makes sense. You go home, you decide to come back, you come back to college, but you're not happy, so you come back, and that's when you change your major instead of changing it before you leave. And then it's nice when data makes sense. So here's graduation. Here's the fraction graduated. So you get to kind of the 4th year, and people start graduating, which is cool. And so I will consider that from Sarah after the talk, so I'm not sitting here reading a long text. Okay. And the graduation hazard also makes sense. You have a lot of people graduating after 4 years, a lot of people graduating after 5 years. Okay, but part of this game is we'd like to know, what influences what. And to do that, we're going to look at correlation. Correlation is just a mathematical way of telling you whether one variable varies the same way as another variable. So a positive correlation would be maybe height and weight. Taller people are generally heavier. So two variables that increase together would be positively correlated. Two variables that are negatively correlated, if one goes up, the other goes down. And so let's look at factors that might be, now we're going to drill down to just coming back after your fall freshman year, after the first year. And this is the third visualization again in this talk. This is a visualization of that correlation. Green lines are positive, those variables vary together. Red lines are negative, those variables vary oppositely. And the green dot I've drawn is the good thing. You come back as a sophomore. The two red things I've drawn are the two modes of leaving engineering. One is just leave college, and one is to leave engineering for a different major, generally non-STEM major. And the surprise was those two things are most tightly correlated with different stuff. So leaving college in general seems to be most related to HS GPA, which is high school GPA. And these ACTs are ACT, verbal, and math, and there's a bunch of AP classes here. And these transfer classes are way off in space because they don't seem to relate to anything. And you see first generation status very weakly related, and rural status, you'd have to have a good monitor to see there's slight red lines there. But leaving college seems to be related to being successful, meaning you do well in high school classes. But leaving engineering is more related to this Cal ready, which means being math ready. We've talked about that before. A student is considered math ready in engineering if they are ready to enroll in the 1 semester Calculus 1 course at their first semester of college. And so not being ready to start in calculus really puts you behind in an engineering major and extends your time to degree. And it looks like it's related to also the decision to possibly not pursue an engineering major. All right, and that is, I'm sure I'm out of time, right, Caitlin?
Yes, I've been sending super secret messages to you on chat, but I don't know if you've seen them giving you a countdown. Yes, you are out of time.
All right, I'm out of time. I'll stop there. I had this great plot, which I'm going to skip. We can talk about that next meeting. This is how it actually looks. So, and there was a long question from Sarah, but I don't even know if I have time to take that.
Yes, you have 5 minutes for questions.
Okay, Sarah, could you, I don't know if it's she, could you simply ask this? So interesting thought. Does this graph suggest to anyone that we should be targeting first generated, underrepresented rural students, that is adding rural students who are not first gen or underrepresented? To me, so here, so first, and this is what Elaine's working on. It is turning out that you know, the additional risk to first generation students shows up pretty clearly. But the additional risk for rural students is um, very much more subtle, I think, because being rural is a very non-uniform thing. That if you went back to this graph, just you can see how these AP classes are very much related to these general academic things that are definitely affect leaving college. And you know, rural students may have very variable access. I think, I don't know if Margie's going to talk about that. We've looked at that. To those classes, they may have more access to these transfer credits, which would be, these are first-time freshmen, so these would be dual enrollment credits often, or things taken at local community college, which seem to be much less related to affecting how their ACT scores or high school GPA is, and then less related to even college. But that is a high school by high school thing, basically. So Elaine's task this summer is to unpack all this data we have about West Virginia high schools and see if we can understand that relation. But it's definitely not a uniform. There's higher risk for rural students, definitely, but it's much more subtle, the effect of having a rural upbringing. All right. So Caitlin, is it time to turn it over for Margie, or is there time for additional questions?
I'm going to open the floor for one more question before we move on. Does anybody have a question they'd like to ask John?
Wow, that's weird. When we were in person, this generated a million questions.
Well, it was deep, so probably people are processing, and I think that's awesome. So, oh, we do have one question. Will you be sharing these data on the website?
I actually assumed this was being recorded, and that we'll have the opportunity to upload our slides. Talk about this next time. You know, part of the issue we have with telling you how rural and first generation student retention is different is that that requires us to understand the retention of non-rural first generation students, and this picture shows how complicated that is and that we don't. So
yep. All right, we're going to go ahead and transition to our next research team of Marjorie Dara and Roxanne Humbert. We have some questions in the chat, but we will try and answer them if we have time at the end. Otherwise, we'll get back in touch with you. So Marjorie and Roxanne, I'll turn it over to you. And I just want to say that John teed it up very nicely for you guys when he made the point that rurality is not just one thing, that it is not a unitary sort of concept, that there's lots of variation within rurality. And I think that you'll learn some very interesting things about that in this presentation. Marjorie, Roxanne?
Okay, can you hear me?
Yep.
Okay. All right. Hi, my name's Marjorie Dara, and I'm a professor of mathematics at West Virginia University. I've been working with Dr. Roxanne Humbert. She was the former West Virginia statewide coordinator of online learning, and with Leah McGilton, who's our WVU doctoral student in instructional design and technology. We make up the qualitative research team. John and Gay and his students are on the quantitative side. So we're here to talk about what can we say about STEM persistence related to first generation status, locales where students went to high school, and first to network connections. But we're going to look at it in a little bit different way than John did. Okay, so John used a larger data set from WVU. We have been focusing on student participants in the first two network. Our first data set comes from a student survey we give yearly. We actually started with a set of interviews, then we developed the survey based on the interviews. We've given the survey to 3 cohorts of students from the summer immersion experiences in pilot year 1, 2018, pilot year 2018, year 1, 2019, and year 2, 2020. We give the survey in the fall semester, and we have an overall completion rate of 45%. On the survey, there are 3 parts. We talk to them about their first generation status, the opportunities that were available in the locales where they attended high school, and the connections that they've formed in the first 2 network. We collected data from locales around West Virginia also, and we have the following information from each county in the state. The left-hand side is about the county, and the right-hand side is about the school. So the things that we have collected about the county are things like number of libraries, number of museums, public transportation available, number of advanced ed institutions, percent of the population that graduated from high school, percent population that has bachelor's degree, those who have advanced degrees. And then about the high school, we collected the percent high school 4-year graduation rate, the percent college going rate, the average number of AP courses per high school, the median high school size, and then the percent of rural high schools. And again, we're using the same NCES definition that John used for rural. Those last 2 categories we're using. We also have another data set that we're using in this research. It's data from WVU, and we're trying to get at STEM going rates and STEM persistence in the different counties. So this set covers 10 years and has 13,408 students. And we'll explain later how we use the data when we're looking at locales. For the 5-year start date from August 2010 to the start date of August 2014, we have 5 cohorts, and we followed those students through 5 years to see if they graduated. This was just a crude way of getting at persistence in STEM based on the county that they come from. And we're in the process of getting this same kind of data from other schools within West Virginia, but right now we only have it for WVU. So let's look at our first research question. How does the degree of first generation impact the effectiveness of interventions to increase persistence? It's quite obvious that not all first generation students have the same background or the same exposure to people who can help them navigate choosing to go to college and persisting. So many people have lots of relatives or friends who can guide them, and some of the students that we encounter have no one. So we decided to break down the idea of first generation a little bit. First of all, we should note that if we consider them level 0, that's not first generation. So that means that they did have at least one parent who graduated from college. Then we define level 1 to be that they did have parents or guardians who attended college, but they didn't graduate. Level 2 would be they had siblings who attended or completed college, but their parents did not attend. Level 3, they had extended family, grandparents, aunts and uncles or cousins that attended or completed college, but they didn't have parents or siblings who went. And level 4 is they had no one in their immediate or extended family who attended college. So for the 55 students who responded to our participant survey, this is the breakdown. We had 18 of those who were not first generation. They were at level 0. But we had 37 first generation students that we were able to get information from. And this is the breakdown. 16 at level 1, 10 at level 2, 7 level 3, 4 at level 4. Next, for our participants, we looked at how this may have affected their persistence. We found persistence data, meaning we could determine whether they were still in college and still in a STEM major for 55 of our 55 students. We can see that persistence is not all that different, and actually the overall persistence for our students is higher for first generation students than for the non-first generation students. However, it's clear that we had very few students at level 4 And then for those students at level 4, of course, their persistence rate is the lowest. Okay, so let's move on to another area that we were looking at, which is the locale. Okay, a research question in this area is, the research questions are, can we better classify the locales where the student participants live during their middle and high school years by identifying resources they had available in the area? And what resources do students have access to that would have affected their decision to attend college or pursue STEM? Okay, earlier we explained that we collected a lot of information about counties of West Virginia, and you can see the list of information that we collected again on the left. We also collected West Virginia University data by county on students majoring in STEM and on graduating in STEM. This slide shows how we tried to group the counties by attributes. We were looking at which counties were like, and then we wanted to see how these attributes affected students majoring in STEM and graduating in STEM. You can see that these counties have been clustered, and we did it by using k-means clustering, simple clustering idea, using all the attributes. The columns show the centroids of the cluster, or a representative for the cluster. You can see that cluster 1 counties have more resources. They have more libraries, more museums, and more advanced educational institutions. They also have a higher percentage of people who graduated from high school, college, and have advanced degrees. They offered more AP classes per high school, and they have a higher percentage of college going rate. They also have larger high schools. The median size in that cluster was 1,370 students, and they also have a lower percentage of rural high schools in that county. Cluster 2 have less resources. The high schools are a little smaller. The counties on average have a higher percentage of rural high schools. And then cluster 3 seem to have the least resources, the smaller high schools, and they have more rural high schools in their counties. However, the numbers in red, I found interesting that the more rural counties tend to send a higher percentage of students into STEM majors. But for these students, fewer persist to graduation, at least at WVU. The cluster 1 counties actually had a lower percentage of their students who were majoring in STEM, but of those students, more graduated. Here is a map that shows the clusters by color. Cluster 1 counties, which were the better resource counties, are in red. Probably not surprising to anybody who's lived in the state for a while. Cluster blue counties, they had fewer resources, a little less rural. And then cluster 3 counties, the fewest resources, the smaller high schools, and the most rural high schools in those counties. We also collected, this is maybe hard to read, I'm sorry about that, but hopefully you can get closer to your screen if you can't read the words at the bottom. We also collected data from students about opportunities that were available to them in high school and which ones they took advantage of. We collected information on things we called cultural activities, which is this slide, and things called STEM activities. The slide is also, the bars are by cluster. So the red are cluster 1, the blue are cluster 2, and the yellow are cluster 3. I'm sorry, I did not use the colorblind palette like John did. I apologize for that. Most clusters have school-based activities such as school band, chorus, and clubs, not the STEM clubs, but other than STEM clubs. But cluster 1 students seem to say they had more concert halls or cultural centers or playhouses to take advantage of. This slide then shows what the students that we surveyed say they were involved with. You can see that some of the activities are missing yellow bars, the cluster 3 counties, such as the concert halls or playhouses, meaning no one from those counties was involved in these kind of activities. In the yellow counties, the school clubs and school theaters seem very important. Now let's switch to the STEM activities available. So when we asked the student about the STEM activities, we found that students said that the activities were available somewhat equally in all clusters. The only one that's a standout there is the HOSA, which is Health Occupation Students of America student organization, and that was a standout in the more rural counties in the cluster 3. Next, we went to what did they actually participate in? Well, when we asked them what they participated in, we found that some of the STEM activities were missing from the students in cluster 1, the less rural high schools. The HOSA, the VOTEC engineering, and the NASA camps were missing in the cluster 1. Those were the counties that were more resourced. The STEM AP was more prevalent in cluster 1 because we, as you remember, we saw that they had more STEM and more AP in general available to them. When looking at the students involved in first 2, the availability of the dual credit classes, the math field day, the STEM camps were similar in all clusters. However, fewer students in cluster 3 participated in them. This might be an indicator in terms of what was causing students to persist. Next,
4 minutes, Marjorie.
4 minutes. Okay, next we looked at the persistence by locale clustering. This table shows how many students participated from each cluster that we had. Okay, we can see that for cluster 1 and cluster 2 counties, the persistence of participants is fairly high, but for cluster 3 counties, the persistence drops to about 65%. Okay, the last thing we're going to talk about just quickly is these research questions about our network in general. What types of meaningful networks are forming among entities within the state? What are the structure of the relationships that are forming? And what are the best ways that the network can share knowledge and resources to assist students to persist in STEM? We can't fully answer any of these questions yet, but we're starting to look at this through social network analysis. Okay, first we want to look at the growth of the full network. These are, we sent this survey, social network survey, to all participants in the network. And the respondents named who they were connected to and they rated the strength of that connection. So you can see that there's more people involved each year and the connections are also growing. You can also see that there are more leaders emerging within the network. These are the larger nodes, the connections, they have more connections and stronger connections. In 2019, we started giving the same type of survey to the student to look at how the student network was growing. And now we can also see that the student network is growing in number and in connections. Next, I wanted to look at the overlap between the full network and the student networks. In 2019, these are the 2 networks side by side, and you can see that the same people are named in the different networks, and we've showed how they cross over. In 2020, the overlap is more, and you can see that the people who are overlapping are some of the leaders within the network. Okay. Finally, we tried to determine if being connected meant higher retention in STEM. We had 48 of our 55 participants who ended up in these networks. Remember that first year we did not give the students this network part of the survey. Of these 48, we looked at the ones that were still here, and we looked at their connectivity in the graph. And what we found is students who were retained had a higher average connectivity than the ones who had left. So just to sum up quickly, for our participants, first generation students are actually more likely to be retained, but the first generation level 4 students, that's students with no one in their immediate or extended families who attended college, are the least likely to be retained. We also noted that students from cluster 3 counties with less resources and more rural high schools are less likely to be retained in STEM. These students are less likely to participate in STEM related activities. in dual credit classes. And then students who were retained have stronger average network connectivity. What does this mean for the first two network? Well, I just asked some questions at this point. Can we develop more targeted interventions for these first gen level 4 students, either to recruit or to retain them? Can more be done for the cluster 3 counties to help students persist in STEM? And how can we make sure all of our participants get connected into the network and benefit from their connections? And that's me.
Thank you very much, Margie. And we have time for a question or two, if anybody has one at this point. There's lots of interesting conversation in the chat about one of the rural challenges being transportation, that often it's difficult to get to extracurricular activities, particularly if there is no bus for activities, or if there is one, it entails a very long bus ride. Okay, if you think of any questions about the presentation from Marjorie and her colleague Roxanne, feel free to put it in the chat, or we'll share our contact information at the end and you can always email us. All right, well, I am now delighted to turn things over to my colleague, Genevieve Campbell. We are from the evaluation team. And for those of you who aren't clear on the difference between research and evaluation, here's the deal. The research team is trying to learn about rural first generation STEM students and what helps them persist and what gets in their way and what can be done to help them persist through their STEM programs of study. So they're learning about real stuff. The evaluation team, on the other hand, is also learning about real stuff, but the questions we ask are different. Our questions have to do with, how's the first two network going? How are things progressing? Are the first two network members achieving the goals that the network has set for everybody? So that's the difference between what the research team does and what the evaluation team does. So I'm very delighted to turn things over to Genevieve now, who's going to run us through some interesting activities.
All right, guys. So many of you probably are familiar with this, either from high school or from this year's online activities, but I created a quick Kahoot activity. So what you need to do is go to Kahoot, which I put inside of the chat. It's just www.kahoot.it. It was limiting the number of people who could participate, so I made it teams. Hopefully that works out better. I'm not sure who you will be teamed with. I mean, you guys probably know better than I do, but we're gonna give this a shot. So I'm gonna share my screen once I see people joining. Let's see, I can share it now so you guys can kind of see. Oh, I got a team member. Good job, Elizabeth's the first person. We should give her a prize. It is asking me for my team name.
Same.
Just put whatever.
Whatever I want. Okay.
Yeah. You know, it could be colors. It could be, you know, however you feel. Just name your team somehow. Tigers. I like it, Elaine. All right. So I'm going to share my screen now while you guys are adding yourselves to the Kahoot game. That way you can see the questions that when they pop up. Okay. And if for some reason you can't get on or whatever, don't worry about it. Just watch and do it in your head, write it down on your little notepad in the chat. However you want to participate is totally okay. This is just to kind of get you guys thinking about essentially what we think about as evaluators. as it relates to some of the things that we ask you questions about. Some of these questions are related to the working group survey, if you are a participant in a working group. Some are just related to, basic understanding of what we've collected as an evaluation team that you would find in the evaluation report, okay? They're not super difficult questions, but they do require a little bit of thinking. There's only, I think, 6 questions, so this will go quickly once everybody's in, and then we'll move on to the next one. Okay, I think we got a good number. Are we good? Lots of folks. Okay, I'll give you one more minute here. It feels like we're still rising here in our number count, since we have 75 participants in this session. That's awesome. Who does quick math? If we had 120 people register and 75 participants, what's our rate of participation here? First person gets a prize. John is monitoring the chat, I think. He's on mute though.
62.5%.
And who had the first answer, first correct answer?
Josiah.
Josiah, of course, Josiah. Representing. Go ahead, Josiah. Student leaders at work. All right, we're gonna get started. Okay, here we go. All right, first 2, here we go. First question in 2, 1. How much does first 2 STEM students re-enrollment rate differ from the rate of STEM rural Pell eligible freshmen in West Virginia? And that's across all of West Virginia, not WVU, not any specific institution. Gut feeling is usually right. All right, 3 seconds left. Just put an answer in there. Okay. Wow. Okay, so most of you thought the first 2 rate was higher by between 5 and 10 percentage points. It's actually lower by between 5 and 10 percentage points. I think it was 7. Caitlin will talk about that in a moment, but that's good to know that you guys think that, and we'll keep going. Next question, are you ready? Who's up first? Who named their team WVU? All right, next question. What percentage of members of first 2 are students? We've got this. That's based on the last evaluation report. Who read the evaluation report? You guys got this. I gave you more time on this one, and you probably needed less time. All right, 10 seconds left. I think all the answers are in anyhow. All right, I'm hoping to see big things. Oh, 50% is what was in the last evaluation report. In all defense, I'm sure those numbers have gone up since then. So we may be looking at 70%. So those who said green, I'm not mad at you. And those who said 40, you were really close, okay? Here we go. Who's in the lead now? The Newts. Who's the Newts? Go the Newts. All right, Jellyfish is right behind you. Here we go, next question. What is the major reason you believe 30% of first 2 freshmen did not continue with the STEM major as sophomores? There is no correct answer for this. Everybody should get equal points. Just want to get your opinion. Lack of family knowledge about how to help, lack of mentorship or peer support, competing priorities, or inadequate academic or skill building. Looks like most of you think that competing priorities, but it's pretty across the board. Everybody, I would say that's probably true. And we only could pick one. So I get it. All right, this is a true or false. According to first two members, the study stage of the Plan, Do, Study, Act cycle. We didn't hear, okay. Let me move my screen so you guys can see it. Is the strongest feature of the working group PDSA cycle. So according to the working group survey, what did members say? Did they say that the study stage was one of the strongest features compared to Plan, Do, Study, Act, the study stage? True or false? Okay, most of you said, yeah, the study stage is the strongest. In all actuality, it is false. The plan stage was the strongest stage of the Plan, Do, Study, Act cycle. All right, where are we now? Newt's still on top. Panda's not far behind. I don't know who Newt's is, but they're doing well. Which one of the following do members think their working group has made the most progress on in collaboration? Representing the demographic and geographic diversity of the state, group ensures that student perspectives are considered, meet together regularly, or recognize and respect one another's perspectives in diverse forms of expertise. Again, this is just according to the working group survey. Most members believe that their working group has made the most progress in. It may differ by working group, but overall, what do working group members say? What have you made the most progress in according to your members? Good job. Oh no, not good job. Sorry, I misread that one. Okay, well, it's still good. Recognize and respect one another's perspectives. Good effort, but it's really meet together regularly. Most of you actually said that meeting together regularly has really been consistent since the last working group survey went out. So good job. All right, now who's on top? Teal took over the lead. Well, last question. Which one of the following do members think their working group has made the most progress on in capacity building? Okay, this is the section that asks about capacity building. Institutions that lead to sustained impact beyond the life of the network, contributes to changes in organizational norms or institutional norms, assume new roles and develop the capacity to conduct network activities, or organizations allocate resources to support partnership work. What do you think? All right, so according to the membership, in terms of capacity building, working groups are contributing to changes in organizational or institutional norms, culture, and routines on research use, more so than these other indicators, but that doesn't mean that those aren't close behind, okay? Good job, everyone. Let's see who's the winner. Here we go. The Nudes came in third. Caitlin, you were not allowed to play. Oh, okay. Who's the Newts? No. Need a representative from the Newts. Teal came in first. Who is Teal? Put it in the chat. Who are you and your members? NWVU. Good job, everyone. All right, I'm going to pass this over to Caitlin to explain maybe a couple of those questions that we just talked about.
Awesome. Congratulations, everybody. I'm going to share my screen with you real quickly.
Good job, Rhonda. I see your name in there. Good job, Michelle. Way to go.
Can you see my screen?
Yes, we can see your screen.
Excellent. Okay. So I'm going to share a piece of data with you, a finding with you from the from last year's evaluation report. We had our first look at fall-to-fall STEM persistence amongst the 2019 first two network interns. Now, these data are lagging, meaning it takes us a year out to get the data to understand STEM persistence fall to fall. So we learned that there was a 67% fall to fall STEM persistent rate amongst the 2019 interns. Specifically, what does this mean? Specifically, it meant that 5 left college entirely, 2 in turn switched to other majors, one to cyber forensics and one to business. One transferred to another college, but we weren't able to determine their major. And one stepped out of college for personal reasons, but really communicated their intention to return the following semester. 67%, however, is not great. It was not what we were hoping to see. And we wanted to find some kind of comparison. So we turned to our partner at the Higher Education Policy Commission, who helped us look at data from the 2018 cohort of rural Pell eligible STEM freshmen across West Virginia, West Virginia's public institutions of higher education. We do not have first generation status data from the Higher Education Policy Commission because it's not something that institutions have collected or collected in the same way across the state. So Pell eligibility was the closest sort of proxy. There are problems there, and we could argue about that decision to do this, but we wanted to have some kind of comparison. So the fall to fall persistence rate for 2018 rural Pell eligible STEM freshmen in West Virginia's public institutions was 74%. So that is higher. However, do not despair, because one of the cool things about the First Two Network is that the National Science Foundation funded us to learn about how to improve the persistence of the early STEM persistence of rural first generation students. And that's what we see as evaluators, the network members continuing to do by looking at why students leave STEM. The research team is going to do follow-up interviews with leavers to understand, to get a view in on why they left. Members are also doing the hard work of testing new practices and figuring out how to scale those up if they prove to be effective to other sites. And by continuing to build and nurture this network so that more and more people are invited in to help and share what they have learned, what they know, what they understand. So next up, Jonave is going to lead us through an activity to think a little bit more deeply about why it is that we think that First Two students may not have persisted in STEM to the extent that we had hoped and been working toward. So I'll turn it back over to you, Jonave. And please stay tuned because we have an exciting announcement to make at the end of this presentation. This is going to be an award. It is a much sought after award, and we are very excited to award it for the first time. So stay tuned. Jonave, yours.
No worries. So what you're looking at, if you've managed to go to the link, and I see many of you have, I mean, you know, I'm so excited that there are so many of you. So I'm not even sure if they have enough avatars that are animals or insects to cover the numbers that you guys showed up in today. So kudos to you. That being said, don't worry about it. I'm going to share my screen with you. But if you are in, I'm just going to give you a quick opportunity to do something in this space. It's a whiteboard space. It's pretty intuitive. But first, I want to explain what we're going to do. What I put here were 5 of the kind of findings that we shared. The first one is members reported consistent working group collaboration via regular meetings. So a note to that is, even so, how can we really ensure that new people can and do participate more often and in larger numbers? This was one of the concerns from membership. The second finding I highlighted here is STEM persistence rate, that Caitlin just explained, that's 67%. The third here is changes in participating education institutions norms. Don't go moving stuff around. But essentially, that's the finding that we talked about. I'm going to lock that in a minute. Around the use of integrating that into institutional culture. And so one piece is, once we discover a promising practice or intervention, how can we scale its use across more departments and institutions? Okay, that's something to think about. Another finding we talked about was the percentage of active members of First Two who are students, 50%, and that number continues to rise. Finally, the use of the improvement cycle, PDSAs, fishbone diagrams, are at the core of First Two's action. That being said, plan and act phases are the most commonly reported. How can we ensure members are identifying through study cycles as well? Okay, so that's something to consider. I'm going to now move this screen. You guys are in it. Hold on. I'm going to move over here and I'm going to show you another part. Okay, and what I want you to be able to do here is I want you, oh, somebody's moving dots. What I want you to do is inside of each of these questions it asks, this is interesting, this finding that we just talked about, one of those 5 findings that you see listed. This is interesting. And I am currently working on or will plan to conduct a PDSA to learn about more ways to improve this outcome. Okay. If you are interested in doing that for one of these 5 findings, go ahead and put that number in the block. Okay. Put it on top of other things. They don't have to be separate. That's totally fine. Once you've done that for this particular space here, you can actually type inside of one of these Post-its. So I type in like text, I might say, I am working with Dr. Stewart to look into, or whatever you want to put down. So this will help us to follow up or just understand kind of where we are in this space. So if you have some ideas that you have already been thinking about, go ahead and put those in the Post-its, okay? If it's not a finding that you currently are ready to work on, are not planning anything related to it, then those would go beneath, okay? And when I say beneath, I'm referring to the this is interesting part, but I'm not sure how to apply it to my work group. I understand this first 2 finding, but it isn't helpful or relevant to my work group, or I'm not sure what the meaning of this finding is, and I'm not sure if it is relevant to my work. So you guys just kind of play with it. Again, it's a whiteboard. Type in anything that you've been thinking about into the Post-its. And really consider, I think, number 2, hint, hint, STEM persistence. Since that's really the focus of all the work that we're doing, it's important that all of us have an understanding in a way to kind of identify the work that we're doing against that ultimate goal. If you have any questions, go ahead and put them in the chat. I'm going to put myself on mute. All right. Let me see if I can go here. Be right back. Oh, sorry. Okay. All right. Oh, we have a question about Pell eligible, of course. But yeah, so essentially, this is kind of where I wanted you guys to land. It looks like this is interesting, but I'm not sure how to apply it to my work group. Number 5, a lot of people are feeling like number 5 is interesting, not really sure how to apply that. Number 4 looks like it's landing, and I understand this first 2 finding, but it isn't helpful or relevant to my work group. Okay. So we're talking about the active membership of students there. Okay, it's something to think about. Looks like some folks are using the Post-its. I made them pink because I really wanted you guys to focus on number 2 up there. But but you're more than welcome to change the color to match what finding you find most relevant to the work that you're doing. Now, how many of you have used Mural before? No, Kathy? Shaking her head no. What do you think, Kathy? You can come off of mute. You like it? Okay. Yeah, this is a trial mode here. I've been doing it a lot since the pandemic, and I like the colors, I think, more than anything, you know, the color codedness of it. Sometimes I forget to lock spaces and people play with it, but it's okay because you have to treat it like it's a real whiteboard. People erase, people scratch.
Brittany says she hasn't used it before, but it's very cool. And Samantha says that she hadn't used it before, and it might be a bit hard to have the first time on it be with so many people. Yeah, it is a little chaotic, but that's also part of the fun. So
yeah, absolutely. I'm going to zoom in on one of these and read one. Working to start academic mentoring program with first 2 mentors in our learning center. Okay, awesome. And then someone changed this one to purple. Participation can be encouraged even further if meeting times did not overlap with class or lab times. Duly noted. And I bet that's hard sometimes to kind of navigate, you know, wanting to be a part of some of the sessions. Maybe there's a way we can think about how to kind of, would it be asynchronous, you know, working with the groups on some of these PDSA activities in a way to kind of include everyone, even if they can't make the meetings in some way. Something to think about for sure. Any thoughts from our working group chairs while we have this space getting ready to close out? Let's see, let me go to chat. I keep moving this around, sorry guys. All right, so I'll pass it back to you, Caitlin. What I can do for those interested, this does save as a PDF. You can save it as a PDF. You can duplicate however you want to look at it and process. So once it's finished and you guys want to keep working in it, I will share this with Jade, who can make sure everybody gets it at the steering committee or however you want to do it as of interest. Okay.
all right.
Caitlin, on to your announcement.
Yes, thank you very much, Donovan. That was cool. All right, so very exciting news coming up here. Before I share that news with you, I want to tell you a couple things. First of all, that was my cat. I'm sorry, that is not a child no, that is my cat. He has many things to say. Okay, first of all, we would really love to invite you to the next session, which begins at 3:30 this afternoon, Promising Practices and Shared Learning. So more good stuff. Secondly, Sean is going to put into the chat the very brief evaluation survey that I mentioned at the start of this session. All right, yes, drum roll. We are delighted to introduce you to the Working Group Wonders Award. This is an award given to the working group with the highest response rate of members to the working group self-assessment, which is a self-assessment we administer twice per year. And we are just really thrilled to inaugurate this fantastic award. The competition was very fierce when we announced it, and we are so proud and appreciative of you all for participating in this very high stakes competition. So yes, drum roll, please. And let me show you what the winner will receive in the mail from us.
And while she's doing that, remember, this was very close, like so close.
This golden chalice can be yours for simply responding to an evaluation survey. And I am so excited to announce that the working group with the highest response rate, that is the largest percentage of its members who replied to the last working group self-assessment, is Immersive Experiences. Congratulations. We are so proud of you. You will be receiving this in the mail, and you have bragging rights. You can, I don't know, you might want to carry it around campus if that's your thing. I certainly would add it to your profile picture on any platforms that you're on. This is a traveling trophy, however. So this means that your reign immersive experiences is not forever. And you may have to give this up the next time we administer the working group self-assessment. So just be forewarned.
You may have to give it up in November.
That's right. That's right. It is very heavy. This is a weighty award. Again, the Working Group Wonders. Congratulations. All right.